right, good morning, good afternoon, good evening. We are returning and we're going to pick up where we left off, which was slide 9 of our this will be our third video, and we're talking about variables, we're talking about experimentation, and specifically we're going to use these ideas of what a variable is to better understand the experiment we're doing, which we're calling the Ecolicious experiment. So the last video left off on slide 9. We did not discuss this, so we will do it now. But before, let me just do a quick reminder of where we began in our last video, which was we have our Ecolicious experiment, and we're trying to, and our goal for these slides that we're doing in this video is learning the language and some of the steps of a science experiment. Specifically, we're learning about different variables. So in your notebook, again, you should be going back to the notes section after this pocket. So that pocket you made with these pages, you should be turning to page 55 or 56 to continue writing your notes. And again, our experiment is we're trying to create an experiment that helps us understand this mystery, which is what's the human impact on our environment in Burbank. So how are people affecting Burbank and its environment, the air, the water, the soil, how we feel, how we interact, the other wildlife, the other plants in our environment. How is everything being affected by things that we do potentially? So in order to solve this problem or to have an answer or a hypothesis for this problem, we're going to do our experiment. And right now, let's pick up where we left off, which was learning the language. We were talking about identifying problems, which are mysteries that we need to learn more about. We also discussed hypotheses on slide 5, which was our answer to a scientific problem. So anytime we're answering a problem in science, we call it a hypothesis. We discussed what a variable is, and this is where we're going to start up more because we're going to discuss variables even more. So a variable, again, is anything that affects or interacts with something, and it's anything that can cause something to happen. So a lot of different things can be a variable. We went through slide 7. We did an activity for slide 8, and now we're ready for slide 9. Slide 9 just reminds us, if we haven't done this yet, we're going to go to Google Classroom, and we're going to start listing things that we think are human impacts on the environment. Each team will do this. So each team at their table will go onto a computer. They'll open up this Google slide. They'll find their team number, like in the picture you can see team 1, and they'll make a list of, it appears 1, 2, 3, 4, 5, 6 possible variables or 6 things that humans could be doing that affect the environment. And it's brainstorming. It's creative. We don't know if it's right. We're just making a list of what we think are 6 things in your team that could be affecting the environment, or things we're doing that keeps Burbank from being a healthier environment. So what are 6 possible variables or 6 things that people could be doing that keeps our environment less healthy? And then you would list those. Eventually, in the lower box here, we'll use the variables we've listed to try to think of what specific thing do we want to test to see just truly what one thing do you want to see might be making our environment less healthy. And you'll study it in our experiment. So if we haven't done this activity yet, where we work as a team and create a list, we will soon. Chances are you probably already have it. Your team may have already decided which variable you're going to test to see if it affects the environment. Let's continue though. Slide 10. Slide 10 is a definition for experiment. So in your notebook, write slide 10 and copy down this definition. It says experiment equals a method for learning about the effect of variables. It says an experiment helps us learn about what causes something. So this means it helps us understand variables and how they affect something. And an experiment also uses evidence from studying variables to make a hypothesis. So we have to study what affects things to better understand something, and then we can make a claim or a hypothesis to explain why something happens. Because we know this affects this or this affects that, we're more knowledgeable. A good example is you could have a house plant and you could be not watering the house plant, so you never give the plant water. If you never give the plant water, you can expect the plant will die. Water is a variable, and we understand that that variable is very important. And then you can make a hypothesis. My hypothesis is plants will not survive without the water variable. They must have some of the water variable to live. A good example is this right here, variables. There are 3 different types of variables we're going to be learning. But just look at this. This is a list of variables that affect plant growth, possibly. The type of plant is a variable that matters. So the type of plant will affect how plants grow and live. The amount of soil or the size of the container matters. So that's an important variable to decide how the plant lives. The amount of liquid or water you give it, like the earlier example I made, that's a variable. The type of soil you give it, you can have sandy soil, you could have a lot of soil with lots of wood, or you could have lots of soil that are polluted or dirty, right? These are all variables. The size of the container, how much dirt is in it, the type of dirt, what kind of fluid you give it, the type of plant it is, its species. All of these things affect how plants grow. These are many examples of variables that affect plant growth. And in an experiment, you use different variables to really study how each one of these variables affects an organism. So our experiment, we're going to learn how these variables play a role in plant growth. And then we can make a hypothesis from it. Like this. It says we'll use the evidence we learn from studying the variables to make a hypothesis or to answer that problem, which is, so we'll study enough to be able to answer this question. What human impacts affect our environment? We'll know because you've studied the variable and you've measured it. All right, it says slide 10. So in your notebook, you should have written slide 10 and then created the definition for experiment. And then finally, it says in your journal, interpret this definition and write 1 sentence of what you think it means. So in your notebook, you should write under this definition your interpretation. My interpretation is blank. Or you could put, I think an experiment is blank. Or you could put, from definition, an experiment is blank. But you find a way to describe it in your own way to explain what you think an experiment is. Interpret just means read something and say what you think it means. All right. Here was some planning of past students I had a long time ago, and they came up with different variables that they thought were important to study or to test in an experiment. So the student Israel thought, the amount of rain probably plays a role in our environment and affects the health and of our environment. This student thought, I bet with our climate change, or possibly they said we're getting hotter in our city, this may play a role. So temperature is an important variable. This person, Valeria, they thought, I think trash pollution in our environment affects soil, and that's an important variable to test in my experiment. So all these students thought of different variables that they would test in their experiment, just like you. All right, this is slide 12. No need to write anything, but I just want to remind you that anytime we measure and collect data in an experiment, so anytime we're measuring anything in science class, we're always using the metric system. And just to explain why, the green is all the continents and all the countries on the planet that use the metric system. And all scientists have adopted the metric system. So because most of the world uses the metric system, we too practice using the metric system so that we can easily share data and experiment results, what we learn from experiments with each other, and so we understand the measurements because we're all using the same one. Examples of this are meters, kilograms, and liters. These are the three primary metric units we'll use. Kilograms to weigh mass, liter to measure volume, and centimeters to measure lengths. All right, slide 13. In your notebook, please write slide 13. And then after you write slide 13 in your notebook, please get the definition for data. Or I should say the definition for measurements. It says measurements equal data. So it's what we use to support our hypothesis. So if you see HYP, this is hypothesis. And we use our measurements to help answer the scientific problem. So what does that mean? If we're answering a scientific problem, that means we are using to make a hypothesis. Because these two things are the same thing. I'm going to make them the same color because they're the same thing. Let's see if I can choose a good color. All right. Good enough for now. Okay, so when we use our data and the measurements to answer a mystery or a question, a scientific problem, we're making our hypothesis. So the last thing we're going to do is practice this idea of taking measurements or collecting data by watching a video. We're going to watch Forensics on Trial. So it's going to be a quick clip about forensics. While you watch this video, you need to first, in your notebook, where you wrote slide 13, you need to write number 1, and you're going to answer this question. It says, what's being measured or collected as data in the video? So what kind of data or information or evidence are they collecting in the video? And then number 2, you're going to try to answer, what kind of mystery or question or problem are they trying to understand? So why are they taking measurements? So ask a question. Remember, a problem is in the form of a question. So what kind of question are they asking themselves when they're collecting all this data or measurements? Let's begin the video.
The laundry list of forensic techniques that are now scrutinized.
NOVA puts forensics under the microscope to find out how good science can go bad.
I don't belong here. I'm innocent.
And how new technology can serve justice. Forensics on Trial on NOVA.
All right, so first, could you see anything that they were looking at or using or studying in the video? Any of those things would be measurements or data. List those now. Secondly, why were they looking at some of the things they were looking at? Ask a question of what they might be trying to solve. What kind of mystery might they be asking about? So for number 2, you're going to write a question, which is a problem. You're going to write a scientific problem. And it would be like this. So you're going to be trying to answer question number 1. So replay this video if you need to rewatch the Forensics on Trial. So rewatch it for a minute if you need to. But you need to list any things that they were measuring or data in the video. So anything you could see that the police were looking at, or the crime scene investigators, or the forensic people were looking and studying. So rewatch the video if you need to. Anything that they were looking at or measuring or studying would be data. You can list that here, anything you remember from it. And then the last thing is you need to create a question. Why are the cops doing what they're doing? You have to create a question that explains why they're doing it. What are they trying to learn? So a problem might be blank with a question mark. So what is the mystery or the confusing thing that they need to know about? Write that question. All right. This concludes our video. this wraps up our step 2 about experimentation and learning about variables, hypotheses, and problems. Bye.